Alright, hey. Okay, alright, the section that we're going into, section 4.5, we're going to be talking about graphing trig functions. Alright, hey, let's knock it off. I don't
should have heard the opposite.
Alright. Alright. So here's our goal today. I want to graph the basic trig functions. Today, I know it's going to seem a little silly, we're just going to focus on sine and cosine today. Now, when I'm talking about graphing, because you guys are used to like drawing the triangle, setting up sine and cosine, you know, opposite over hypotenuse or adjacent over hypotenuse, that's fine. That's what we've been doing on all the homework up until this point. Especially like the assignment we had, the page 513. That's pretty much all we did. That's not exactly what I want to do today. We need to use the circle chart, what I called the unit circle chart that I gave you last week. Now, if you did not draw this secondary unit circle, I had a lot of people that were kind of, they're like, Ward, I already have the unit circle. It's already on my property sheet. Why do we have to add that second one? It's because of what we're going to go into today. I said I wanted to focus very specifically on just two things and not have all the clutter on that graph. So the goal today is we're going to look at that unit circle that was based on cosine and sine. So if you did not draw that on your property sheet, you will want to fill that unit circle in. Because I know some people said like they saw it's already printed. Today's stuff will only be familiar if you're in physics, I believe. Physics might have done something like this earlier in the year.
Which one?
Where,
what are you talking about?
Where they graphed the trig functions, sines and cosines. This is actually called wave theory. Okay, wave theory. What I mean by that, there's three things we have to learn how to graph today, or three parts. Number one, we have to focus on what the amplitude is.
Oh yeah, we've talked about it.
Yep. Most people have, but I'm going to show you a little bit differently than they probably have. So amplitude. Second, we're going to look at the period length of it, which is, I believe they call the period length the frequency of it. And then number three, we look at the origin.
Oh, period? Yeah, period.
Which is some type of shift that takes place. Now, the goal today is to do very easy shifts. What I consider easy shift, up and down. This is our goal today. I want to do this in about 20 minutes. Hopefully this makes sense. Give you plenty of time to work today. Okay, questions?
How was your weekend?
Nope, not that type of question. Okay, all right, here we go. So, all right, have your notes out. Here we go. Let's graph the sine function first. Okay, now what I mean by this for sine, if you looked at your unit circle chart, this is the chart that you should have on your property sheet. This chart will help us graph the sine function, and I'll talk about what I mean by graphing the trig function with the wave theory. What we talked about last week was on a graph, there was certain angles like 0 degrees, 90, 180, 270, back to 360.
You keep going.
Yeah, it just keeps spinning by 90s. Yep. And I can keep going, but we don't need to right now. All right, now what we talked about on Friday, or it was actually I think Thursday when I introduced this. We had coordinates, and we called this the unit circle because you went exactly 1 unit from the origin. So like this coordinate right here was 1, 0. It was 1 right and left, up and down 0. This coordinate right here is 0, 1. This coordinate here was -1, 0. And this coordinate is 0, -1. Alright, so these were the 4 coordinates we had. Now what these actually stood for, just other than just being, one spot from the origin, these are actually the answers for sine and cosine, alphabetical order, cosine first, sine second. These are the answers for these specific angles, like in order. So what I mean by that is when you're doing like the cosine of 0 and the sine of 0 degrees, the answer is right here. That's your answers for those particular coordinates. So this would be 1, this would be 0. Now I know a lot of people are like, okay, Ward, fine. The chart gives me the answers, whatever. Okay, but it's more specific than that. It actually tells you roughly what your answers are, and you can guesstimate. You can actually make an educated guess at what the decimal is going to be as you move from like 0 degrees up to 90, because it makes a perfect circle. They're circular functions. These trig functions, they're actually circular as opposed to just being on a triangle. And that's why I think it was Reese, I think one day you asked the question, why can't you just set up proportions, I believe, for triangles? And it comes down to this. The reason why we can't do proportions for just right triangles, why can't you just set up certain walls over certain angles, is because they're actually based on circular paths. That's why. What I want to do today is show you the relationship of these answers with how you graph sine. So this is the first day of it. So what we're going to look at is the second result. I'm going to circle this here. We're looking at the second answers for each coordinate. So when I ask for certain angles, I'm looking at the second number for all of these coordinates. So in my case, it would be 0, 1, 0, -1. Make sense? Okay. I do need to plug in the radian measures in here in case, because I know like your unit circles do have radians. 0 degrees is 0 radians, so that one's pretty straightforward. But 90 is also known as pi over 2. Because how I know that? Pi, the symbol pi, other than being 3.14, in radians, it literally means 180 degrees. Pi. Because if you convert it, if you had pi radians, you actually take it times 180 over pi to convert it back to degrees, and it literally means 180. So when you cancel it out. So pi over 2 is 90. It's 180 degrees divided by 2. That's how I like roughly translate it or convert it really quick. 180 is known as pi in radians. Again, these red angles are in radians. 270 is 3 pi over 2. That's 270. And then back to 360, this would be 2 pi. How I know that? Because here's how I calculate really quick. This was 1 pi over 2, right? This would be 2 pi over 2, 3 pi over 2, 4 pi over 2.
Where do you get the 2?
It's because what I talked about earlier is that pi means 180 roughly radians. So when you divide it by 2, that gives you 90. 180 divided by 2. So then you had 3 of them to get to here. You had 3 90s. So 3 pi's over 2. So it's kind of like a common sense way. Now, all I'm doing with that radian measure is putting those in there, because when we graph a trig function, your calculator has to be in radian mode when you graph it, if you have a graphing calculator. One of these. You would not, if you left your calculator in degree mode and you try to graph like the SIne function on the graphing program, it wouldn't look right. If you change it to radians, it automatically applies it to circles, because that's where radians come from, because they use pi, so they're based on circles, and it will actually show you a wave. Okay. Now these wave theories, what we actually use them for, we use them for sound waves. We use them for radio waves, Bluetooth, Wi-Fi, any type of electronic signals are in some form of wave. Even light is some form of a wave, and there is a formula that you can attach that can actually give you that correct spectrum, so that you can actually hear or see it, which I think is pretty cool. Like different bands of light have different frequencies, like the period's stretched. So that's in space. That's one of the things that they use for NASA to calculate if a certain star or planetary object is going a certain direction from us. Like, is it going away from us, or is it coming towards us? And what I mean by that is, if they're orbiting a star and they're looking at like a planetary body, which they're doing right now a lot of the time, they're trying to figure out which direction is it orbiting. Is it going, clockwise or counterclockwise? Because they can tell is when it shows up, it shows up as a certain spectrum of light, usually reds and blues, to the human eye. And they can tell by that color it's coming towards us or away from us. Because the human eye, if it's coming towards us, it's compressing light and we see reds. If it's going away from us, it would turn blue because it would stretch it out longer. It's one of those weird things where there's a ton of math behind it, tons of sciences, but But today, the goal is to look at just the sine function, and then we're gonna look at how we can adapt these to make different things.
This will work.
Okay, question?
If you had to guess how far a football could be thrown in space and continue to move, how far would you guess?
Ball?
Yeah, like they took it.
Well, if there's no like gravitational force interacting on it, like a star or a planet, it would just continue to float if you actually put force behind it in that same direction.
I looked it up yesterday, and it's 565,000 yards.
Yards. Before what?
I think before like,
Your gravitational force would,
well, I think
Theoretically
before
hit
your
it.
force become like there is no more force.
oh,
Like-
so it degrades over time?
Yeah, like.
But that
it's-
would require
Low.
some form of gravitational body interacting with it. If there's no gravitational
Well, I
force
mean,
pulling on it, it wouldn't stop. There's no, I mean, it's a vacuum, so.
That's what
Okay.
I
But let's focus back on this. Interesting though. All right, okay, here we go. We're gonna graph the sine function today. So this is what I like you to write down. We're gonna graph the sine of theta. Okay, now what I mean by this is what I like you to put. I would like you to put a coordinate plane down, but the right side of the x-axis goes really, really far. Along that major axis, the x-axis, I'd like you to put 4 hash marks. What I'm about to show you is one picture length of what the sine graph looks like. One picture, one snapshot. Now it continues in both directions without limit, but I'm giving you one period length, one picture of it. Okay? Now, how this works. Shh. Okay. How this works. This spot right here, along the x-axis, these are going to be my angles. This is going to be theta. This is going to be my angle measure. As I go this direction, this is going to be my angle measure. Okay? As I go up and down, this is the actual value that the trig function would spit out. So we're in control of the angle I plug in. Okay, that's my independent axis. I'm in control of the angles I plug in. Now, this would obviously be 0 degrees, 0 radians. Okay? This will be pi over 2 radians, 90 degrees. Then 180, 270, and 360. Okay, hey, stop talking. You're getting annoying. I'm going to kick people out. I'm not going to have it today. If I'm going over something new that's hard enough, good luck to you learning on your own. Alright, so for these values, when you look at the sine function, now this is where I was talking about, you have to look at this unit circle. What is the rightmost number? What's the highest point that it hits on the right?
1.
1. What's the lowest number it would hit?
Negative 1.
-1. So on the values it would spit out, we would have to hit 1 as the tallest point, -1 at the lowest point for the range. Now what we're going to do is we're going to graph sine. And I'm roughly going to draw like dotted lines, and we'll fill it in as we go. So at 0 degrees, 0 radians, what's my answer for sine?
I'll go say.
0. Okay, we start here. So we're starting on the origin. Okay, as we go up to 90, what's happening with my x values? Or my numbers? As it goes from 0, what is it going up to?
1.
1, right? That's the second number, that's sine, right? Sine is the second number. It's going up to 1. So as it goes closer to 90 degrees, this thing is climbing in a kind of an arc till it hits 1 right at 90 degrees. Now, as we get past 90, or pi over 2, whatever you want to call it, as we get past 90 degrees, what happens? It goes back down because we approach 0. So it's going back down to 0 again. So we reached like a hilltop. And again, it's a very perfect circular like path, an arc. Now, as I go past pi,
Goes to -1.
it goes to -1. So now it's going down below, and it's going to -1 once it hits 3 pi over 2. That's 270. Okay? And then as we get back to 360, because we were at -1 there, as we go back to 360, what's my second answer? 0. So we're back to 0 again. This picture, what you're looking at right here, this is one unit length of sine function. Okay, it's a wave. Now, obviously we continue right and left, but now why this is important. If you were to, and this is going to seem really weird, there is a way to chart water waves, like actual liquid waves in the oceans, and they can actually put functions on them so they can chart where the peaks and valleys are. This is something that what do they call it? The aquatics nature centers would keep track of, like with buoys out in the ocean to see where the peaks of waves are, because they can keep track of altitudes from the origin line, so they can keep track of altitudes. And this is how they initiate a tsunami warning. When they notice a certain earthquake, so the seismographs would go off. But then when they start to see the buoys that are out in the middle of some of the oceans offshore, and they see the water levels rise or lower, they know they issue the tsunami warning in the countries where its direction is headed. Which is, but again, it's coming off of this type of function, right? That they actually plot ocean waves based on these functions, and they can match it perfectly. You know, wind would compress them together and make them taller in certain cases. That's why they have waves offshore. There's lots of things that impact these, but this is the idea. Also sound waves. If you were to take I'll try to bring a video tomorrow, where if they were to strum a note on a guitar, or a bass guitar, right? You would actually see the string itself wobble if you put it in slow motion. Because it's using a sine or cosine wave to mimic it. That's how its sound is compressed. It comes at you in waves, and that distortion is how you hear pitches. Some people are tone deaf, which is really crazy to me, that they can't hear difference in pitches, like highs and lows.
I thought that was just like a joke.
No, it's really it's real. I had a relative, I think it was a cousin, the second cousin. He can't hear difference in highs and lows. So when he sings, it's terrible to listen to him. It's really bad. Like he can't match pitch at all. He just can't hear it. And I'm just like, do you even hear like the note that's being played and what you're singing? He can't tell the difference. Like,
Oh, that was just like, oh.
so like music to him is always very bland. He just doesn't like music because he doesn't hear the differences. He listens for words, not music, like actual notes, which is very different than most people.
That's confusing.
So,
Because what note do you hear the whole time?
so for him,
Or is it?
yeah, for him, rap makes a lot more sense because he can listen to the beat and the words as opposed to like instrumental music. He doesn't listen to that. So.
I was never used to instrumental.
That's insane.
I thought that was just like a joke for somebody who's a bad singer.
No. They use it as a joke, but it's literally a thing. They can't tell the difference in frequencies. Their brain can't interpret that. All right. But yeah, this is the thing we're going into, and this is just like the first point of it. Like today was just to intro what we're going into, like the vocabulary terms. But we're going to look at all the trig functions, how to graph them the next 2 days in here. So like tomorrow's going to be kind of right off the bat. We're going to jump right in. We'll talk about the sine graph again, but we're going to mess with it a little bit, like shift it, change some things, and I'll try to show you the video of the instruments so you can see that. Question?
Okay, so can he like hear the difference in people's voices then?
No, because voices, like everything to him, like he can tell like his mom versus dad. But the problem is he doesn't like register like highs and lows. It's very weird to me. Yeah, like he just doesn't catch that. So for him, he can't catch like sarcasm a lot because he doesn't hear the inflection in the voice.
Sure he doesn't.
Yeah, like right? Yeah, like that. Like most people catch that, they can see that. He doesn't catch that. So it just to him, he just seems like he's.
That's insane.
Yeah, it's really funny when you talk to him, but
I wanna look up.
yeah.
Are you gonna make the class tomorrow?
How-
Does he have a very
So-
monotone voice?
All
Or
right.
no?
Yeah, it's really bland. Yeah. All right. God, I hope he doesn't watch this. I'm never gonna tell him about my website ever. All right. But anyways, you have the remaining 20 minutes today to work in your assignment. We're gonna go over this stuff more tomorrow, and I will talk about those 3 vocab words I've written on the board. Question?
Does that mean something's wrong with his ears or his brain?
It's the interpretation from his ears to his brain. He can't register it.
I feel like that's something you